So students, welcome to your first class of basic electrical engineering subject. So this course, basic electrical engineering, okay, and the code for this course is E L E ELE 150C. So in this course, we will study the basic elements and the basic terminologies, basic theorems of any electrical system. Okay, so this course will comprise of 5 units. 5 units. Hope the visibility is, there's a visibility issue. The video is not properly visible. Let me try another pen. Okay, yeah. So this course comprises of 5 units. Okay, so let me write down the name of the units first. The first one is DC circuits. You must have read in your physics electromagnetics that we have two types of systems, AC system and DC system. So the circuits which comprises of AC sources are called our AC circuits, and the circuits which comprises of DC components or DC power supply, it's called as DC circuit. So DC circuit, the first unit is DC circuit. So in this circuit, first of all, we will study the basic elements of any electrical circuit. Basic elements. What are the basic elements of any electrical circuit? The basic elements are resistance, it is represented by R, inductance, represented by L, this is the symbol, and capacitance, represented by C. So R, L, and C. How will you represent a resistor? A resistor is represented like this. And how an inductor is represented like this. And a capacitor, it can be represented like this or this. Okay. So what are the types of resistor inductors? We will see when we'll discuss it in detail. So these three are the basic elements of any electrical system. So these are the basic elements of any electrical system. Next, in this chapter, we will discuss the various sources. Okay. What are the sources? Sources can be voltage source or current source. Right now I am discussing the syllabus. We will discuss these voltage source, current source, how they different, what are their characteristics. We will study it in detail in the coming classes. So how voltage source is represented? A voltage source is represented like this. Okay, this is plus, this is minus. Okay, this is some voltage, I will say V, and I have another source here, plus minus, and I am using this symbol here. This is again V. So this symbol, sorry, I cannot show plus minus because polarity will change after every half cycle. So this symbol here This symbol represents AC. You can say I'm showing a AC sine wave here. So it represents AC. So these are the two sources which we will study, that is voltage source and current source. Then we will come to the basic laws that are used in electrical engineering. Basic laws. There are two basic laws: Kirchhoff's current law and Kirchhoff's voltage law. Now Kirchhoff's current law, it is represented as KCL, and Kirchhoff's voltage law, it is written as KVL. So in short, when we will say apply KCL, means apply Kirchhoff's current law, and if we will say apply KVL, it will mean apply Kirchhoff's voltage law. So once you will know what is study about how to apply these two laws, what is current source and what is voltage source, and what are the and how these circuit elements, that is R, L, and C, will behave, only then you will be able to carry out the analysis of simple circuits, electrical circuits. And electrical circuit can be a simple or a complex circuit. So after that, there are some theorems. In your course, only two theorems are there. Number one, superposition theorem. Number two, Norton's. Okay. So these are the two theorems which we will study in this course. Though there are many theorems, like we have Thevenin theorem, maximum power transfer theorem, Milliman's theorem, and many more. So, but in this your syllabus, only two theorems are mentioned, that is superposition theorem and Norton's theorem. So these theorems we will apply in this DC circuit. Okay. So chapter number 2 or unit number 2. So in this syllabus, in this unit we will discuss about the DC circuit, how these circuit elements will behave to a DC power, to a DC source, and what are the sources. We have voltage source and current sources. These voltage sources and current sources, they can be AC or DC. Here I am only showing the voltage sources, but one is DC voltage source and one is AC voltage source. I am not showing the current source here. Okay. Next, we will study the basic laws of electrical engineering, that is Kirchhoff's current law and Kirchhoff's voltage law. So these three things, basic elements of electrical circuits, their characteristics, then sources, voltage source and current source, and the basic laws, that is KCL and KVL, they are the base of the electrical engineering. So if you know these three things, basic elements, sources and basic laws, only then you will be able to study electrical engineering, because these things will be application of these three, they will be used in every subject in the higher semesters. Okay, like when you will go for this networks theorem, control system, or power system, or machines, there you will you can only understand if you will have a good knowledge of these three things: elements, basic elements, sources, and basic laws. Now this was about the AC circuit, DC circuit. Though now the next chapter is about the AC circuit. Unit number 2. AC circuits. Okay, so in AC the magnitude keeps on changing with respect to time. This is AC. Okay, this is AC. So it is time t is equal to 0. This is omega t when time corresponding to angle is pi by 2. When sorry, this is pi by 2 here. Pi by 2, this is 2 pi. Okay, 2 pi means 360. Okay, so you can see as omega t increases, okay, the value increases up to which point? Pi by 2. Then again it decreases. Okay, at pi by 2 the signal is at its maximum value or peak. This is called peak. Okay, so in AC circuits, first we should know about the sinusoid. These are the sinusoidal waveforms. We should know about the sinusoidal waveform. We should know about the how to calculate the peak value of the sinusoid and what is the RMS value, root mean square value of the sinusoid. Only then we will be able to move further. So in AC circuits, firstly we will study how to represent sinusoidal wave. Okay, and how to calculate peak value of a sinusoid, how to calculate RMS. RMS means root mean square. Root mean square value. How to calculate RMS value of a sinusoid. Okay, how to represent the sinusoidal phasor representation. What is the difference between a phasor and a vector and a sinusoid? We will discuss it when we will study this chapter, that is AC circuit, chapter number 2. Okay. Now we usually talk about power. So this power, it is a component. It consists of two powers: actual power, that is active power, and reactive power. So next we will study what is active power and reactive power. This active power is also called as real power. So we will see what is active power and real power. In case of DC, there is no reactive power. Okay, but when we talk about AC, we have to study active power as well as reactive power. However, in DC, reactive power is not there. Okay, and what is apparent power? What is apparent power? How we calculate apparent power if we know active power or reactive power? If we know two, we have active power, reactive power, and apparent power. If we know 2 out of 3, we can calculate the third power. Okay, that we will see. After that, power factor. What is power factor? Most important. What is power factor? Because we will see the significance of power factor. What will happen if the power factor, in short, it is simply cos of phi. Okay, so you know that cos, it can be between 0 and 1. Okay, it can be between 0 and 1. So if power factor is on the higher side, that is, it is closer to 1, so we will see that it is advantageous. When the power factor is on the lower side, that is closer to 0, we will see that it has got a number of disadvantages, which we will discuss. Okay, so after that we are talking the AC circuit. In an AC circuit, we have single phase system, and three-phase system. So how will we what is single phase, what is three phase, how are they two different from each other, that we will C. Then resonance, you must have read it in physics as well, just an introduction to that. Then we will see how to solve series and parallel RLC circuits. You know that R is resistance, L is inductance, and C is capacitance. I told you. Okay. So then we will see three-phase circuits. What is the relation? Okay, one important topic I left here. So we know that series and parallel combination of RLC, but there are certain we have a three-phase system. So the three-phase system can be three-phase system. It can be star is represented like this in the form of Y, okay, or delta is shown like this triangle, okay. It can be star or delta connected. So for star we have different relation between voltage and between voltage and current, and for delta we will have different relations, okay, which we will study in this chapter. So this was all about the AC and the DC system, okay. DC system is quite easy to understand, whereas AC system, it is a complicated system, not difficult but complicated. So if you can read carefully, so there will be no problem in this AC circuits as well. Because in the AC we have single phase and a three phase. Single phase is easy to understand, but when it comes to three phase system, students get confused. So if we will move systematically, first we will study the DC system, then we will study AC single phase system, and then we will study AC three phase system. So that there will be no confusion, okay. So these are about unit 1 and unit 2. Next is unit number 3. Unit 3. So unit 3, unit 3 is transformers. So basically we don't have to go into detail of this transformer action or how this transformer construction. We don't have to understand this. In transformer we are mainly concerned with the magnetic phenomena that are taking place inside the transformer. So we will study for transformer. Firstly we will study the magnetic materials. Magnetic materials means what type of magnetic materials are suitable for transformer construction, and what are the characteristics, what are the magnetic characteristics of those materials, okay. So magnetic characteristics, we can for magnetic characteristics we will study the BH curve characteristics. Okay. So then, and in this practical world, nothing is ideal, okay. Though we say that ideally ideally an instrument should behave like this, but like in some manner, but practically it is not possible, because in realistic world nothing is ideal. So same is the case with the transformer. We have ideal transformer, we will study the characteristics of ideal transformer, but as I told you, nothing is ideal. So we will study ideal transformer and practical transformer. Okay, ideal transformer and practical transformer, and how this transformer is represented diagrammatically, means how the whole transformer, that is transformer has two windings, primary and secondary. These windings have certain resistance and leakage reactances, and also we have some magnetizing current is there in the transformer. So how this transformer is represented electrically, that is called as the equivalent circuit. Equivalent circuit of the transformer. If I am writing like this, so it means it is transformer. But you will not write it like this, you will write it like this, transformer. So what is the equivalent circuit of a transformer, and what are the losses that are taking place in a transformer? Losses in a transformer. You know, this transformer, it is made of this it consists of this copper windings and this core. Okay, so what will happen, there will be some losses in the core and there will be some losses in the copper winding as well. Okay, though the losses in the copper winding, it will depend upon what is the load connected, how much load is there in the system, because higher the load, more will be the current. Okay, so losses in the transformer, what are the various types of losses in the transformer that we will study. Then another important aspect or characteristics of any transformer is its voltage regulation and efficiency. So if the voltage regulation and efficiency, they are not good, voltage regulation means how much voltage is changing on the load side when we change the load from no load to full load. Okay, so voltage regulation and efficiency is the next topic. Again, then three-phase and single-phase transformer. Then after that we will study three-phase transformer connections. Okay, so this was all about the third unit, that is transformers. Then we will in unit 4, so we studied transformer, but in electrical engineering, one of the most important component of electrical engineering is the electrical machines. What are the electrical machines? Electrical machines, like we have generators, motors. Though there are many types of generators like DC generator, AC generator. In DC generator we have certain different classification, and in AC generators we have different classifications. Same is the case with motors. So electrical machines, I'm not here, transformer is shown as a separate unit and electrical machines is shown in as a separate unit. However, in certain books you will see that transformer is considered as a machine, or as a precisely they write it as static machine. But as per the definition, if we look at the definition of electrical machines, so the definition says that any equipment or any device which converts mechanical energy into electrical energy or electrical energy into mechanical, it is called as machine. However, in case of transformer, it is not converting any energy. The input to the transformer is electrical and the output is also in electrical form. That's why we kept it as a separate topic, separate unit. So in this case, generators, you know that in case of a generator, the rotor is rotated, and but you know only that. But how it works, we will study it. I will give just an introduction to this in this chapter, because this is a separate subject, electrical machines, which you will study in the higher semesters, which is electrical machines 1 and electrical machines 2. You have two subjects, and one more course is there, that is special electrical machines, which is elective course. Okay, so you have 3 courses on machines. So here we will only study the basics of the electrical machines, like how rotating how rotating field is generated. Okay, then construction and working of electrical machines. What are the components of electrical machines? In construction, we'll see the different components of electrical machines, how these components are created, what are the characteristics and functions of those components, and how these electrical machines it works. Okay, so after that we will study, sorry, I will write it here, three-phase induction motor. So significance of torque, slip, character, significance of torque, slip. What is torque? What is slip? Torque, you don't know slip, because slip is we only study slip in case of this induction motor. So that is why I am writing it here below this three-phase induction machine. So what is the significance of this torque, speed, slip characteristics? So how these motors are started? Induction motor, starting of induction motor. Starting of induction motor, then working principle, so last we will study how construction, and at last we will study construction of synchronous generators. Synchronous generator means the generators that are used in power hoses, also called as alternators. Okay, so we will only study the construction, nothing else. Okay, now the last topic unit is unit number 5. So this unit is called as electrical installations. In this unit we will discuss about the basics of the basic electrical equipments that are used in a day-to-day life, like you must know how fuse works. You all have seen fuses in your houses. Okay, so here we will study what is fuse, why is it used. Then we will study MCBs that are used in our houses. Okay, then the types of wires, and cables. These wires can be made of copper, it can be made of aluminum. So but for basic electrical we talk about the wires that are used in our houses, means that is copper based wires. So there are different types, it depends upon the what is the current handling capacity of the wire. Okay, so then we will study what are the different types of earthing, types of batteries, what is earthing, and what are the important characteristics, types of batteries, and here I will write characteristics of batteries. So this was all about the syllabus of this basic electrical engineering course. So this syllabus is divided into 5 units on DC circuits, AC circuits, followed by transformers, electrical machines, and electrical installations. So what are the basic elements of an electrical circuit? So that I will tell you in the next class. So this was all for your lecture number 1. Because on the first day it is not good to start with the course directly. On the first day it was important that I should give you an overview of the course. So this is all about the overview of the course. So in the next class we will discuss the basic elements. We will start with the first unit, that is DC circuits, and we will start the basic elements of any electrical circuit, that is R, L, and C. Okay, and if time allows, we will also discuss the various voltage and current sources. Okay, thank you very much.